So continuing on with our lesson that we started there earlier, we're going to be taking a look at how do we solve for a side length of a right angle triangle. Based on the relationship that we saw prior, and I'll go back to those prior notes here, this relationship right here of the three squares. Okay? So based on the relationship that was shown above with the area of the squares, an equation can somewhat be listed here. And we're going to list it off using the areas here. So we can say that the area of a square, and now it's not a square, it's the a square, okay, plus the area of the b square is equal to the area of the c square. Okay, so the a squared plus the b squared is equal to the c squared, and to find that using our to find that using the length that we have, we're going to write it out in this form right here, and I'm just going to put this into. It's going to be a squared, which is a times a, plus b squared, which is b times b, is equal to c squared, which is c times c. So this is our equation that we're going to come up with. Okay, this right here is what we call Pythagorean theorem, okay, or Pythagorean theorem, depending on how you say it. There's a couple different ways to say it, and so Pythagorean. If you have another way of saying it, it's another way of saying it. Okay. This equation is a relationship which connects all three sides of a right angle triangle. Okay, and it's called, as I mentioned, the Pythagorean theorem. Okay. It was, now again, we call it the Pythagorean theorem, but in fact it was developed thousands of years ago. There's a lot of speculation as to who developed it or who came up with it. It was officially kind of named long after it was determined, after the philosopher named Pythagoras. Pythagoras. There we go. Okay, it was named after Pythagoras, Greek philosopher, way back, kind of back in the BC era. So back before we started counting up by days, or if we want, in this modern era that we would consider. So we've known this theory for as Pythagorean theorem for the last couple thousand years, but it's been known for even longer before that, even before Pythagoras was around and was a philosopher. Now, using this formula, if two sides of a right angle triangle are known, then the third can be found as well. So we're using this to solve for the third side of a triangle. Let's find the third side of the triangle. So first thing we're going to do here, we've got an example. We have this side is 5 centimeters, this side is 12 centimeters. We want to try to find what is our third side. And so we're going to trying to find the hypotenuse. First thing that we do is we label our sides with A, B, and C. Now remember, A and B are interchangeable. We could call this one B and this one A. That works as well. But this one will always be C. So that one will always be C. Okay. Next, we place into the equation, and we're going to solve for C squared in this case, because we're trying to solve for C. So our equation, and I didn't leave myself quite enough room here, I don't think. A squared plus B squared equals to C squared. And if I'm going to put in those numbers, A is 5 centimeters squared plus B, which is 12 centimeters squared, is equal to C squared. I'm just going to slide this over so I can do my next line in a different color over here. Now, 5 squared is 25, and 12 squared is 144. And so these two combined are actually going to give me the value 169 centimeters squared. And that is equal to C squared. Okay, so we've squared them both. If we do it on a calculator here, I'm just going to quickly open up my calculator. There it is. Okay, 5 and squared, oops, plus 12 squared equals 169. Okay, so 5 squared plus 12 squared is equal to 169. So that means that c squared is 169 centimeters squared. Now, we need to make sure that we want to find just c. We're not looking for c squared, we're looking for just c. Remember, that means that this if we think of a big square on top of here, is equal to 169. So what we need to do is we need to take the square root of both values. And so we're going to take the square root of this number, and we're going to take the square root of this letter squared right here. And so that's going to give us, if we do the square root of 169, we're going to get 13 centimeters. And if we take the square root of c squared, we're going to get c. And so this tells us that c is equal to 13 centimeters. Now this turned out to be a really nice one. 169 is a perfect square. Okay, so we can recognize it as a very nice number, but not all of them are going to be like that. Some are definitely going to give us decimals, just like we saw with when we solved for square roots of numbers. Because we're doing a square root, it's often going to give us a decimal unless we're given a perfect square. Now this one right here, okay, you'll notice that we have 5, 12, 13, no decimals. This is called a Pythagorean triple. Okay, as all three sides are natural numbers. Often, when we do questions, then we're gonna come up with all sorts of different like decimal answers. Usually, be a decimal answer. Every once in a while, we're gonna get one that where all three are perfectly natural numbers, and those we're gonna represent as Pythagorean triples. Okay, they're kind of a rarity, so to speak, but they're really nice to have. And I'll probably use some examples in class as to why they are really nice to have. All right, let's solve for C. Let's do a couple of examples. These may or may not be Pythagorean triples. This one definitely won't because it already has decimals in there. So we're just going to have to kind of deal with that. All right, let's solve for these. This is C. I'm going to call this one here A. And I'm going to call this one here B. Okay, I'm going to put my equation up here once for both these. B squared is equal to C squared. Okay, I have A, B, and C. Yeah, it's better. All right, so this is 5 squared. And notice here we don't have any units, so we don't actually have to worry about putting units in. 5 squared plus 10 squared is equal to C squared. And C squared is equal to, let's use a calculator for this, 5 squared, sorry, plus 10 squared is equal to 125. So this is 125. And the square root of 125, remember that what we are doing here is we are taking the square root of that answer and the square root of this one. And that's going to give us that C is equal to, now if we go again to our calculator and we take the square root of the answer, it equals 11.18. So therefore C is equal to 11.18. Key here is that C will always be along a side, so 11.18 needs to be longer than the two sides. It is, and so we know that that could in fact be our right answer. All right, next one here, you'll notice that our triangle's kind of flipped around a little bit. So we have our hypotenuse on the bottom, which is different than the other ones. Normally the hypotenuse is on top, but it could also be on the bottom. So we have 3.5 squared plus 5.8 squared, and that is equal to C squared. All right, 3.5 squared plus 5.8 squared. 3.5 squared, sorry, plus 5.8 squared equals 45.89. Yep, that makes good sense. So c squared equals 45.89. I believe it was. Let me just double check. Yep. And then remember when you take the square root of our answer and we get 6.77. So when you take the square root, get c is equal to 6.77. Again, it's longer than the side length, and so that is the most important part. Remember that we have, I'm just going to go through this really quickly here, we took the square root of these two, and it gives us c is equal to 6.77, which is in fact longer than that side. All right, so that is looking through Pythagorean triples as well as how to find our hypotenuse. In the next video, we'll take a look at how do we find one of the legs.